8.1, the sine law. So the sine law describes algebraically the relationship between the lengths of the sides of any triangle and the sine values of the angles opposite them. So the sine law is used to find angles or side lengths of non-right triangles. Okay, so now we're moving into non-right triangles. Chapter 7 was all right triangles. We use SOHCAHTOA and we use Pythagorean's theorem. And now what we're going to do is we're going to move into non-right triangles. Okay, so I call it a matchup, and what we need is a matchup plus another piece of information in order to use the sine law. So what a matchup is just simply an angle and its corresponding side length. Okay, so to find a side length, a lot of students like to put the side length maybe on the top so that it's already in the numerator, and then we would put A over sine of angle A, B over sine B, C equals sine C. And then to find an angle, a lot of individuals like to put the angle in the numerator again, just so that it's easier to cross multiply and solve. So these two are interchangeable. And even if you want to find a side length, you can still use the angle formula. And if you want to find an angle, you can still use the side length formula. It's exact same. It's exact same equation. Because pretty much what we're doing is, if you see C and sine C, okay, take a look at here. We have side C and we have angle C, right? So all we're doing is finding the ratio between the side length and sine of the angle, okay? So what I did is I showed you 3 matchups down here. So angle A and side A. If you have both of those labeled plus any other piece of information, you can use sine law. Angle B and side B. Again, you can use sine law if you have angle B, side B, and any other piece of information. When we say any other piece of information, we mean any of the other 2 angles or any of the other 2 sides. All right, so for example 1. Example 1 says find the length of the side labeled C, corrected 2 decimal places. Okay, so let's first find a matchup. So I see that angle B and side B are both labeled, okay? And we have to solve for side C, but we have angle C, so this is perfect, okay? So by having a matchup and another piece of information being the 23 degrees, we can solve for side C using the sine law. So because we're solving for a side length, let's just keep the side length on the top. So we have C equals C over sine C equals B over sine B. Okay, so we're going to leave C at the top. Angle C is 23, so we have sine 23 at the bottom. Now B is 15 over sine B, so sine 77. Okay, and all we do is divide and solve. Okay, so I'll solve all of these individually just so that you can see all the steps, but really I would personally skip a lot of these, and as we continue, I will start to skip steps. Okay, so sine 23 is 0.39073. Okay, and then we have 15 over, and then sine 77 is 0.97437. 0.97437. Okay, we want to cross multiply that up. C equals, we would get 15 times 0.39073 over this denominator, 0.97437. That's got stuck. And then all we do now is actually multiply. So 15 times 0.39073 divided by 0.797437, I get 6.015, so 6.02. Okay, and I'm going to put units because this question does not state what kind of unit it is. So the side labeled C is 6.02 units. Okay, now let's just actually think about that. So if this is 6.02, so 77 degrees is 15, and we know that those are in like a ratio, so they're in proportion to the 23 and the 6. So sine 77 over 15, those are bigger numbers. And now sine 23 over 6, those are going to be smaller numbers. And if we actually sub the 6.02 back into where the C is, these two ratios right here, let's go, these two ratios right here, you'll get the same thing. Okay, and that's the whole point of the sine law. Okay, example 2. Find the side lengths, find the lengths of the side labeled y, correct to the 2 decimal places. So first, let's find a matchup. I have x right here. Okay, this is a matchup. We have side x and angle x. And just remember that angle x is a capital X and side x is just lowercase x. Okay? And we have 52. So we actually have z. So we can't really solve for y yet, but because we have 2 angles, remember we can just simply do 180 minus 52 minus 59. And we can solve for angle y. I get 69 degrees. Okay? And now that we have angle y, we can solve for the opposite side, which is side y. Okay? So because we're solving for a side, let's put y over sine y. Okay, we'll put the side on the top, and then we'll do x over sine x. Baby x over sine capital X. Now let's sub in. So y over sine 69 equals, and then we're going to have 8 over sine 59. And this is where I'm actually going to just start skipping steps altogether. So I'm going to put y equals, and we're just going to cross multiply. So this becomes 8 sine 69 over sine 59. Okay, and I'm actually just going to sub this straight into my calculator. Okay, this is I would much rather see this on maybe an assignment or a test. This format right here, and I get 8.71. 71, and that's going to be in meters. Okay, box your answer. There we go. Okay, and now let's think about whether or not this is practical. Okay, so 59 and 8, and we have 69, which is a bigger number, and we have 8.71, which again is a bigger number. So that's quite okay. It's very reasonable to have this as an answer. All right, now find the measure of angle A. So this is the first angle one that we're going to deal with, okay, in triangle ABC to the nearest degree. All right, so we have angle B and we have the opposite side. So we have this matchup, angle B and B. Then we have side A, which is good because we actually are looking for angle A, okay? That's what we're looking for. So let's set this up, but this time let's actually put the angles on the top. So let's go sine A over A equals sine B over B. Okay, so we have sine of, what's sine A? A we're going to leave because we're actually going to solve for A. Okay, over the side A because it's little a, and that's 8. Now we're going to do sine B, angle B, which is 37, over side B, which is 5. Okay, again, let's actually just cross multiply. So what we're going to get is we're going to get sine A, okay, sine A equals, we're going to cross multiply the 8 up. And again, we learned this last section. Don't put the 8 beside the 37 because we just want to make sure that we know that the 37 is not being multiplied by the 8. It's 8 and then sine 37. And just as a reminder, sine doesn't mean anything without that angle right next to it. Okay? So we have 8 sine 37 over 5. And we can go ahead and put that into our calculators. And we get sine A equals 0.96290437. And I kept all of the decimals there. And the reason is because right now what we're actually going to do is we're going to inverse sine both sides. Okay, so we can't divide both signs by sine because we want to get A by itself. We actually have to sine inverse. Okay, the problem with that is when we're applying a trig ratio, either sine, cos, or tan, what happens is if we don't keep all of these decimals, it's not going to be accurate at all. Okay, so inverse sine that, and we get 74, and that's it rounded, 74.3. So 74 degrees okay, and let's see if that's practical, see if that's reasonable. 74 is bigger than 37, and the side 8 is bigger than 5. So yeah, that's quite practical. Okay, so again, leave all of the decimals here. You can even try it. Try to put 0.96 into your calculator. This is what you're going to get, 0.96. This one actually doesn't change. This one's still 74, but as you round more and more during these questions, it's going to get more and more off. Okay, and those few little decimals are going to count. All right, example 4. In triangle ABC, so this one doesn't actually have a diagram, so let's go ahead and draw it. And I draw pretty much all of my triangles the same. Mine sometimes always look like equilateral triangles. So we're going to have the triangle ABC. And we have angle C as 65.6. So let's write that right in there. 65.6. Okay. Angle B is 38.2. So we have two angles. That's good. And then we have side B is 54. And that's in centimeters. But we have to find a side C. So no problem. This question is kind of just testing if we can draw the triangle. Okay, so we do have this matchup right here. We have side B and we have angle B. It's kind of a mess, I'm sorry. And then we're looking for side C. So because we're looking for a side, let's put the side on top, C. So C over sine C equals, and then we're going to have B over sine B. Okay, now let's just sub in. We don't know C, that's okay. Sine C is sine. Let's extend that a little bit. Okay, 65.6. Okay, equals, and then we have B, which is 54, over sine 38.2. Okay, again with this, don't actually solve this yet. Cross multiply. This is such proper form, 54 sine 65.6. And also, if you leave all of this in this form, you will not have to round and you will not have to write down all those decimals. So your answer is going to be more accurate. Okay, so that's divided by sine 38.2. So I get 54 times sine 65.6 divided by sine 38.2. And I get 79.5. Yeah, let's go to one decimal. That's fine. 79.5. And in this case, we were talking about centimeters. Okay, then just decide if it's reasonable. 65 is bigger than 38, and then 79 is bigger than 54. So this is reasonable. All right, so let's recall. To actually solve a triangle means to find the lengths of all the unknown sides and the angles. Okay, so to solve means to solve 3 side lengths, 3 angles. So example 5, triangle PQR, solve it. Okay, solve triangle PQR. Round angle measures to the nearest degree and side lengths to 1 decimal. Okay, that's usually how it is. Angles are usually just to the nearest degree. Okay, so we have to figure out what matchup do we have. Well, we have this Q. We have angle Q and side Q. Okay, and then we have side R. So what we're actually able to figure out is angle R. Okay, so let's go. Let's put the angles on the top. Okay, so we have sine R equals over R equals sine Q over Q. Okay, so we'll go sine R over 41 equals sine 39 over 28. Okay, now let's just take a wild guess. When I look at 28 and 41, which one's bigger? Okay, the 41 is bigger, and therefore the opposite angle is also going to be bigger. So when we solve R, I'm going to tell you that it better be bigger than 39 or something's wrong. Okay, so let's actually cross multiply this 41 up. We get sine R equals 41 sine 39 over 28. Okay, so let's just keep this here and let's type this into our calculators. 41 sine 39 divided by 28. Okay, I'm going to write all these decimals down because, again, when we apply any trig function, sine, cos, or tan, what happens is 0, 4, 8. What happens is the decimals are going to be really thrown off if we don't keep all the decimals while we complete the question. So to get R by itself, we cannot divide by sine. What we need to do is sine inverse. We need to sine inverse both sides. Here we go. Sine inverse. Okay, sine inverse and sine cancel out. We are left with R equals, you know what, I just keep that right in my calculator. I press sine inverse, and then it comes up 67. Decimal. Oh, that's it. Degrees. Let's leave that at 67 degrees. Okay, so we have R 67 degrees. Now, to solve for angle P, it's really easy. All we do is we take 180 minus 67 minus 39. Okay, 180 minus 67 minus 39, I get 74. Okay, 74 degrees. So now we've almost all solved it all. We have all 3 angles. Now all we have left to do is P, side P. Okay. We can actually make an extension onto this ratio. I'm going to extend this by 1. I'm going to extend this by sine P over P. Because again, the P is in the same triangle, so it's going to have the same ratio as sine R over R or sine Q over Q. So we actually have the entire sine 39 over 28. So let's sub in sine 74 over P. Oh, this time, actually, I'm glad that I did this because I kind of want to go over it. But this time the P's in the denominator. That's okay. We can bring the P up. We can bring this 28 up. So let's actually split our screen now. So let's go P sine 39 equals 28 sine 74. And now let's divide both sides by sine 39. Those cancel out. Okay, that's sine 39. Okay, so now we have P equals 28 sine 74 over sine 39, and you just plug that right into your calculator. 28 sine 74 divided by sine 39. And we get 42.8. One decimal place. 42.8. And that is going to be measured in, let's call this units. All right, so we just solved the entire triangle, and we can label this over here, 42.8. Okay, now let's see if it's reasonable. So which one is the smallest side? 28. So 39 should be the smallest angle. Which side is the biggest side? 42.8. So 74 should be the biggest angle, and then 41's in the middle, 67's also in the middle. So that's very reasonable.